A dive, and we're gonna see all the cool pool creatures, like leftover band-aids. Marine Biologist. It is Sunday morning, about 10 a.m., and today is scuba checkout day, so we get to start going through the procedure of getting approved to be official divers for Walla Walla University. So this is usually a fun day. We get in the water and it's been a great day. Had the first half of scuba checkouts today. So we spent some time in the classroom, and then we spent some time snorkeling just here in the bay, getting students used to being in the cold water, getting a little bit used to their gear. Yeah. And then we moved on to the pool, did some skills tests and refreshment in the pool. And then we're pretty much done for the day. Went home and had some dinner. Enjoyed some time with my family, which was very, very nice. Wonderful. But now it's time to take care of some more work. So I'm back into the lab for a while.
When are we diving for our first octopus?
Well, I'm hoping that we can get out as soon as checkouts are over. It might take like a day after checkouts, and then we can go diving. But we need like these tanks ready to receive octopuses. We have stuff to feed them. Now we need a place to put them. And once we have those two things, then we go dive.
Picture this.
Okay, I'm picturing it.
What time are you done with checkouts tomorrow? Like 2 or 3?
I have no clue.
Probably later. We said that we were going to go dive after lunch.
Okay, so maybe 4 o'clock.
Okay.
So 4 o'clock, we're done with checkouts. We hit the lab.
Okay.
We get all the tanks ready.
Okay.
By 9 p.m., we're getting ready to go diving and catch octopus. By midnight, we have 10 octopus. And then Tuesday morning, we're doing research.
Well, Tuesday morning, then we're sleeping or something. Let's see here. Hypothetically, that could be done. I think I'm getting close to finishing up in here for the night. It's close to midnight, so I'd hope so. But I guess that it means it's a good time to kind of explain how the controllers for carbon dioxide in the tanks work. But essentially, this is a data acquisition unit that connects to the computer by USB right here. Then also connects to our sensory probes, pH probe, a temperature probe, a salinity probe. And then also has this block of outputs, analog outputs, digital outputs. What we use there is we can output from these to this switch right here that then we have piped in heavy-duty power cords to. What this will do is it'll essentially take these, we plug these into the wall and then plug the item that we want to have in here, either a solenoid valve that is sitting on a CO2 regulator on a CO2 tank, or a chiller or something else like that onto these, and we can then turn it on or off based on a signal from the computer. So essentially what happens is data comes in through here to a probe into the sensor DAC. That will send the data then by this USB to the computer, which then has this program. So this brings in the data. You can see pH, temperature, salinity here, and it's reading this in, and that makes a decision based on a set point that we put in, whether or not to turn on the CO2 or to turn on the chiller to control temperature and carbon dioxide in our tank. That then sends a signal back to this sensor DAC that then tells it to turn on something on the switch that then turns on the thing that we want. And in that way we can control carbon dioxide and temperature in these tanks that we're running, which is essentially our experimental parameters. So what we did is we went back, we made a second generation of these, which is essentially this. Same thing, it has all the same internals in here. Here's our USB in, and then we have our power cords coming out of there. Everything's all nice in this box, a little bit more secure. So I've been making these, and essentially here is one in the works right here. I'm putting this sucker together. You can see it looks kind of similar to the other one. So yeah, that's what I've been doing tonight, and now I'm putting together the rest of this box. This should be closed up tonight, and we should be ready to roll. So that's what I have going on here. One thing that you can kind of see, this is where my research is at the moment. And one thing I can kind of attest to, this is the family of labs that I come from. Family of labs that descends from a physiologist at UC Santa Barbara, Jim Childress, who was one of the pioneers in deep sea physiology. I've never met him actually, but my master's advisor and my PhD advisor both were PhD students of his, and both of them got from him kind of this tinkering, do-it-yourself, I guess I'll call it kind of a sci-punk sort of ethos. That hopefully I'll be done here in about half an hour putting this together and have some things ready for tomorrow to roll out. Talk to you tomorrow. Enjoy your night. I hope you've enjoyed this episode. If you have enjoyed it, please give it a thumbs up, subscribe. Thank you for your time.